So let's go ahead and look at S1. What is S1? How would I say that in English? It's the symmetric group on the set of one element. It's the set of all bijections between the set containing 1 and the set containing 1. So this is the set of all permutations where pi goes from 1 to 1. Okay? So let's go ahead and see. How many input elements do I have here? 1. Could you come up with a set of all functions? So we'll call this the first function. What is the only input I can choose here? 1. How many outputs can I choose? 1. So this is called the function definition. First function via function notation. And this is actually called the identity permutation. So this is called the identity permutation. Can you guess why it's called the identity permutation? What does it do to the set of inputs? Does it change the input? No. Keeps it the same. It's the identity. It's the equivalent of 1 in multiplication, right? If you multiply by 1, you do nothing. If you apply the permutation P, this permutation, you do nothing. I wanted to show you a few different ways to visualize. Actually, I'm just going to show you one today. This is another way to visualize this permutation. You could think about this as the domain space, and you could think about this as the codomain, and maybe we'll actually visualize codomain. And then here we have our first permutation, or the identity permutation. Why is it the identity permutation? Because all elements in the domain get mapped to their identical versions in the codomain. Okay. All right, so guess how many actual permutations are in S1? 1. So we'll just call it pi identity. All right. What is S2? Well, let's just go ahead and name it. It is the symmetric group on 2 elements. So this is going to be the set of all permutations pi, such that pi goes from 2 into 2. All right. And then I should actually say this, the set of all permutations on 2, which is the set 1, 2. Okay, so here we go. Let's do the first permutation. And let's do function notation first. So here we'll do function notation, which is my least favorite notation because it's so clunky. And then down here we'll actually do permutation diagrams, I think we called these. I actually forget, to be honest with you. There's like 5 different ways to visualize permutations that maybe only 3 that I can think of right now, but I think there's more than 3 actually. Okay, so here we go. Each permutation has to have an input and an output. What is the set of inputs here? What are the things I'm allowed to put in? 1 and 2. Let's start with the easiest map that hits all elements and doesn't do it more than once. Okay, pi of 1, 1. Pi of 2, 2. Could you guess what we call that permutation? The identity permutation. Because what does the identity permutation do? Yeah, not a damn thing. It literally maps 1 to 1 and it maps 2 to 2. How many other permutations do we have here? Well, let's try one more. What are the 2 inputs that I have? Either 1 or 2. Well, my first one, I said 1 went to 1, 2 went to 2. I want a different permutation. What's my only other choice? 1 goes to 2 and 2 goes to 1. This thing looks like this. 1 goes to 2, 2 goes to 1. This is an example of a permutation that is very, very special. It's called a transposition. Transposition. only swaps a pair of inputs. How many total permutations are in this set? What is the symmetric group? It's a set of functions. What's the symmetric group? It's a set of functions. It's a set of bijective functions. So what's the symmetric group on a set of two elements? It's the identity permutation that maps 1 to 1 and 2 to 2, and it's the unique transposition that maps 1 to 2 and 2 to 1. How many total elements are in this particular one? 2.